All right, recording has started. The situation that we have to test more and more functionality in ever less time is something that we see for a lot of our customers. And that seems to be happening more and more frequently. And if you have the same problem, then you are in good company. This here is a slide with all the companies that registered for the workshop until last week. And so I think you can see that this is not a problem that is constrained to one domain or one way of building software or one type of organization or one programming language or technology, but rather we see this problem across all of these aspects of software development and across all of the varied customers that we have. And I want to show you today how test gap analysis can help you deal with this problem. And in the first part of the workshop, I will talk about test gap analysis in general. So what does it do? How does it work? Why do we want to do it? In the second part, Raphael will give you some examples from actual practice where we use the analysis and how our customers are using it, and also go into a little bit more detail about how it works technically and how it's being set up. And then in the last part, my colleague Jakob will give a short demo of the tool so you can see how it works in action. And then in the very end, I will give a little presentation about a study that we did at one of our very good customers, Munich Re, where we looked at the cost-benefit ratio of the analysis in their setting. Before we go into the actual nitty-gritty, here's a bit about our company, because I don't know how well you know us yet. We are CQSE. We've been around for over 10 years now. We originally came from TU Munich as a startup from there, but we've spread across all of Germany, and we also have an office in Sunnyvale, California, so in the Silicon Valley, for our American customers. So if you are Germany based, there's a good chance we have somebody near you. We make TeamScale, a tool for static and dynamic code analyses, and one of these analyses is the test gap analysis that we're showing today. So much for us. Let's get into the test gap analysis. As testers, we're always faced with the problem that we don't have enough time to test everything that we would like to do. So we have limited time, limited resources. How can we still get the most out of our test? Meaning, how can we find the most bugs in the given amount of time that we have? And there's a lot of research on this. And in research, this field is called defect prediction. So you give me a software system, and I tell you where all the bugs are hidden. And of course, if we could do this perfectly, then testing would be super easy. Unfortunately, in practice, it's not that easy. But there's a lot of research on this, and the big result from hundreds of research papers and many years of defect prediction is, for long-lived software systems, most bugs are hidden in code areas where we recently made changes. And as testers, this is not going to surprise you very much. I think everyone has this intuition that if we make changes in the software system, those are error-prone, and we should do a comprehensive test of all changes that we make. And most people try to work that way, and that's a good idea. But the way we do it has some problems, because how do we try to make a comprehensive test of all the changes that we recently did? We look into tools like this, like Jira, like Azure DevOps Work Items, and so on. These are just examples that we had in the past for our own software development of TeamScale. Now we use Jira. When we were very few people in the beginning, we just put some cards on a whiteboard and shuffled them around. But in the end, these tools just record what kind of functionality or bugs did we address in the current release, in the current sprint, and give you some details about that. And then we as testers can go to these tools, and we can look into these issues, and we can decide for each issue, how can we do a comprehensive test of the changes that were done there. And that's a good idea in principle, but in practice, this has some limitations. The first one is, if we look at these issues from the issue tracker and categorize them into different categories here, then there are some where we as testers have a hard time deciding how to do a comprehensive test. So we did this for about 2,000 tickets from our own issue tracker. And for the two categories on the right, it's very easy for me as a tester to decide what I have to do. So this is perfective, which means we implemented a new feature, or corrective, which means there was a bug and we fixed it. And then as a tester, what do I have to do for the new feature? There's a description of what the feature should do. There's maybe some requirements. I can go through that and try to exercise the feature as fully as I can in the time that I have. For the bugs, it's even easier. There's a clear description of what I have to do to trigger the bug, and I do that. And if the bug doesn't happen, then I have done a comprehensive test. So for these, that's easy. For the other two categories, it's a lot harder. What do they mean? Adaptive means something in the environment of our system changed. So for example, we upgraded a database driver or the operating system version, or some external system changed their API and we have to adjust our system so it still works. Preventive means developers did some changes to the software system that don't change the functionality, but they make it easier to maintain, like make the code more readable or less duplicated and so on. For these changes, if I'm a black box tester coming via the UI or some API and so on, it's very hard for me to decide what do I have to do on the UI level to make sure all the database driver changes are covered. Because those could be all over the place in the system, and I, as a tester, probably don't know where they all are. And so I have a hard time making a really comprehensive test. And in the study that we did here, these kinds of changes amounted to 15% of the issues. So that's a pretty significant part of the work we do as testers, where we don't know exactly if we ever covered all of the code changes that the developers did. But this is only the smaller of the problems with this testing approach. The larger one is that in this ticketing system, not all the changes that we do on the code level are actually documented there. And this starts with simple things like developer did a refactoring while they were implementing a feature, and they touched some code areas that are not clearly related to the feature. Then I, as a tester, don't know about it if the developer doesn't write this in the ticket description. And let's be honest, most of the time people don't write this stuff in the ticket description. Or they were implementing the feature, and while they were doing it, they found a bug, and of course they fixed the bug because they want to make the system better. But if they don't write that in the ticket description, I, as a tester, still don't have a chance to know that they did more than is said in the description. And this goes up to situations that we saw at some customers where there's a lot of political pressure on a project. And we had one customer where they had the directive that only the highest level of ticket priority is allowed to be implemented. Everything else is forbidden. But one of the guys from sales knew a person in development very well, and they had already promised a low priority feature to a customer. So they sat on their lap until the developer implemented that feature. But of course, the developer didn't write that in the ticket system, because then people would come asking, why did you implement that? We said we don't want to implement these features that are low priority. So things like that can also lead to changes happening on the code base that we as testers never even know about. And then, of course, we can't make a comprehensive test of these changes if we don't know about it. So for these varied reasons, there's a lot of stuff happening on the level of the code that we as testers never see on the level of these issues in the ticketing system. And this is just gut feeling and anecdotes. We wanted to know how much is that in practice. So we did a study with one of our customers, Munich Re, a big reinsurance company from Munich here, where we looked at one C# system that they have. This is the typical business information system. And for 2 releases of that software system, we looked at all the code that the developers changed, which is the bubble on the right here. And we looked at all the tests that they executed, from unit tests up until manual tests via the UI. And they also had some automated UI tests. And we looked which parts of the code were covered by these tests. And then you obviously get some code that has not been changed, but where the regression tests run through. And you have some code that has been changed for the release and where people wrote tests for that. And then you have some parts where developers made changes, but the testers didn't execute that code at all. And we were interested in how much is that in practice. And so for these 2 releases, we looked at the numbers. And what really surprised us was that they always changed 15% of the code. And over half of those changes went to production completely untested. Even though Munich Re has a very structured testing process. So for every Jira ticket, there's a test expert that goes over the ticket and tries to make a really comprehensive test of all the changes that were performed there. And still, over half of the code changes that the developers make it into production completely untested. Now, in the second part of the study, we did the following. We looked at all the production defects that were reported for these releases. And for every defect, we traced it back with the developers to the exact line of code that caused the defect. And then we looked into which of these areas does the line fall. And this was the less surprising part of the study. It just confirmed our intuition that we had before. It's 5 times more likely that a production defect is caused by one of these untested changes than by the rest of the system. So in summary, not only is there a lot of code changes that make it into production completely untested, they also cause the majority of production defects. Or in other words, if we turn it around, wouldn't it be nice if we knew before we made a release where we still have these untested code changes so that we can react to them and mitigate the risk that they pose? And this is the whole idea of the test gap analysis. We want to show you these untested code changes before you do the release, while you still have a chance to adjust your testing behavior so that you can address the risk in time and hopefully then in the end have less production defects. How does that work? On a very high level, we need on the one hand, what changed in the software system. We get this from your version control system where the developers check in their changes. Teamscale connects to that, and then we know all the changes that the developers did, regardless on which branch it happened, when it happened, and so on. And then the second piece of information we need for the test gap analysis is what happened during the tests. Which code was executed when the testers were executing automated tests or were clicking manually in the UI. For this, we install a so-called profiler on your test environments, and this records while the testers do their tests which methods are being executed and reports this back to Teamscale. And then the test gap analysis does the rest. It aggregates the code changes and the execution information and shows you in real time the untested code changes that you have. And to show you what that looks like in the tool, I have to introduce a visualization. This is called a tree map. A tree map is basically like a map of your software system. Every big rectangle you see here is a component of the software system. So for example, we have here some business information system where we have a big component with some UI-based dialogues, and then some smaller components with things like authentication and so on. And the more lines of code there are in a component, the bigger the rectangle. So this contains a lot of lines of code, and this over here, not so much. And what I'm going to do now is I'm going to drill down into each component. So what you see now is every black rectangle is a class in that component. And if I go one level deeper, then now every black rectangle is a method in the component. And still the size of the method in lines of code corresponds to the area of the rectangle. So over here we have a very large method, and down here we have some small stuff. What we have remaining now is the dimension of color. So we can give every rectangle a color depending on what the analysis thinks about it. Let's start with the code changes. Here now, every method that is gray has not been changed since the last release, and everything that is colored has been changed. So either it's completely new code, developer added it completely new to the system since the last release, then it's red, or the method was already there, but they made some changes, then it's orange. So here you can get an overview over where the changes happen in the software system. You can do the same thing for the execution information that we get from your tests. Now, gray means not executed during test, and green means executed during the test. So green is all the areas where the testers were active during the testing for this release. And then, of course, this works the same for manual and automated tests. So we can record this test coverage information for your automated tests, where maybe you already do this for some subset of your tests, but we can also do it if testers are manually clicking through a UI or something like that. The technique is the same. And then finally, we can aggregate that and show you the untested code changes. And this looks like this. Everything that is gray has not been changed by the developers. And it's gray regardless of whether it was executed during the test or not, because this code is not so interesting for us. Here we know that the probability of production defects is rather low. We want to focus on everything that has a color, because there we know this has been changed by the developers for this release, and that the production defect probability is much higher. And a colored method is only green if the last change to that method was executed during the test. Or in other words, everything that is red and orange, developers made some changes here, but this code was never executed in that version during the tests. So if there's bugs in the red and orange parts, which is rather likely, we can't have found them yet. So these red and orange parts, those are the ones that pose the actual risk. And this is what we want to focus on with the analysis. And this we give you for your software system while you are still testing. So if you imagine you get this picture here for your own system, the next interesting question is, what are the red and orange areas? Why are they there? And do we have a problem here or not? And how can you answer that? For that, you need to bring both testers and developers into the same room, or virtual room, post-corona, probably virtual room. The important thing here is, if you look at this picture and you see large red areas, what you can do in the tool, and we'll show this later on in the demo, is you can drill down what kind of code is this, what changes happened there. This is something that the developers are good at. They can tell you exactly what changes they did there and why, for which feature, and so on. And then the testers can answer the question, why did we not test this yet? Maybe we're still in the middle of the test phase and the tests haven't happened yet. They're scheduled for next week. Then it's okay. Maybe the testers didn't know that there were code changes there. And this is something that we need to adjust in our testing behavior and plan some additional tests. So when you put people together and they work together with this tool, you usually get a list of additional test cases that you want to run to cover some of the risks that you identified. And then the testers do that. And since all of the above data collection is set up to be completely automated, once the testers have completed their test, you get new results here in the team scale visualization, and you can see the new test gaps and immediately see if the test that you did had the impact that you wanted, and you addressed the risks that you wanted to address. And if not, then you now have a nice feedback loop here where you can continue to run additional test cases and then look at the results until you're happy with what you see in the visualization. And then you can make a decision, can we release or not at any point in time. Two important caveats at this point. First, the goal here is not in the end to have everything green, i.e. have 100% change coverage. Because we started out with the problem that we as testers don't have enough time to test everything. And usually that doesn't change because we introduce test gap analysis. We still don't have enough time to test everything. So the tool is not meant as a way to get you to get everything green, but rather we show you the risks, and you as testers still have the job to do this risk analysis and decide which of the red areas are test worthy and which are not. Because there may be good reasons that you leave something untested. For example, the change was trivial. A developer changed the button color from green to blue. If that didn't work, then okay, so be it. That's not a major problem. We don't want to spend our testing effort on that. Or maybe it's very hard to test or not even worthy to test. Maybe it's just a code change in some internal admin tool that your customers never get to see. And if that didn't work, then it's easy to do a quick fix and nobody will be impacted. So there are a lot of different reasons why things should remain untested. So the goal is not to have everything green in the end. And even if we had everything green in the end, so 100% change coverage, that would still not mean 0 bugs, because with testing, we can only ever show that bugs are present. We never can show that there are no more bugs. And that, of course, doesn't change with the test gap analysis. So the goal here is always to just show you where the risks are so that you as testers can make smarter decisions about which test cases to run and do more risk-based testing. All right, so far for the theory part. If you have any questions about how the analysis works in general, now would be a good time to ask them. After that, we'll go into some practical examples of how our customers are applying the tool.
Yeah, good point. I mean, I have a general question. When you say you are comparing what was, how to say, changed and what was tested, so with this color coding, I mean, what are you actually comparing? I mean, where is the baseline? Release branch, or, I mean, somewhere you have to, you know, compare something with something else. Yeah.
Exactly. Yeah, a very valid point. Thanks for bringing that up. I didn't make this explicit. So this is actually very flexible in the tool, and different customers do different things. What you do is you decide on one point in time on one certain branch where you want to start the analysis, and then another point on maybe the same branch, maybe another branch where you want to end the analysis. And TeamScale then traces all the code changes between those 2 points and tells you what the test gaps are. And the usual scenarios are, I want to check my release. So you will choose the start of the release and the end of the release as the baseline and the end date. Or maybe you work more sprint based, and some people also do like start of sprint, end of sprint, and things like that.
Okay, so this is more based on a planning organizatoric, what is your, how to say, increment you are delivering, so on an incremental level. Okay, got it.
Exactly, and of course also how you do branching differs a lot between our customers, so we're very flexible to support all the different use cases that people have. Different branching models.
Super. And another one is, I mean, you said, okay, you are, I mean, the changes you're getting from the commits, so from Git or whatever system you're using, and for the what you're actually covering within your tests, it's practically the profiler is from your point of view provided, what I understood, which is then practically tracking what tests have been executed at which, I don't know, test stage, so unit test or UAT or regression. I mean, looking at it from a big picture, okay, what was tested at all, I mean, is one thing, but do you also need to know, I don't know, the start and the end of each test case, you know? Do I have to tell the profiler, I'm now starting this scenario or this unit test case or whatever? Or is it just, you know, can I have a drill down which test case is covering what, or is it just the look from the top, what was covering it all? Yep.
Excellent question. Thanks a lot. So for this analysis, it's enough to just record normal test coverage. So we don't need to know which individual test case is covering what, because we're only interested in finding out where the big risks are, which is where we don't have any tests at all. And then we don't really care which test is running for which code. But it's possible to do this recording, and we have support for that as well. So we can, with the profilers that we have for most programming languages, also record which test is running through which code, so that you can do this drill down, which test is running through which code in the tool. We use this for other analyses, like the test impact analysis, where we try to speed up your tests by using this information to only select tests that actually run through the code changes that you did. So you don't have to always rerun all the tests, but rather you can only selectively rerun the tests that actually bring you value because they actually cover the code changes that happen.
Okay, because the reason why I'm asking this, I mean, if I think on a release branch, which I don't know, is taking 2 weeks, 3 weeks, in the beginning of the release or when the first user stories are getting committed there, I'm testing them, but at the end, maybe the same things are, you know, changed again, but maybe not covered in the tests after they got changed as well. So that's why I was asking this, in this direction.
Yeah, but for this question, I think the normal test gap analysis is sufficient, because we would be recording while you do the release branch, we would be recording all the test activity that happens, and in between we send the data to TeamScale, and TeamScale is smart enough to understand that you changed the method, then you tested it, and then you changed it again, and then it will still show you as a test gap.
Okay, got it. Super, thanks.
You're welcome. Any more questions? Nothing in the chat either, I assume?
No, nothing in the chat.
Then I would hand over to you, Raphael.
Yep, I'll take over the screen. All right. Right, then now for some practical examples. But before I go into that, I want to start with some technical details for you to better understand the examples. And I want to go into some more detail on what types of data or what data we need for the analysis. Fabian already mentioned that we need two types of data. The first is the changes, and we get these directly from the version control system. This is a bit different from some other static or dynamic analysis tools that are connected to the build. TeamScale connects directly to the version control system and retrieves every single commit. And the second type of data is the test coverage. And here, as Fabian already mentioned, we use coverage profilers. Those attach to the application that we want to analyze and instrument them. Instrumenting in this case means you can imagine that they add some additional lines, and these basically just say I've come past this point. And from this, we then get a report that can look something like this when it's visualized, where we have green parts which have been executed. In this case, also yellow parts, which means it has been partially executed. So, for example, one branch of an if statement has been executed. And red, which has not been executed at all. And these two types of data we then combine, and TeamScale then calculates the untested changes. As was also already mentioned now, we often have different types of tests, like component tests or unit tests, which test just a single entity of code, like a method or a single class. Then we have integration tests, which tests several units working together and how their functionality works together. And then at the highest level, we have system tests or UI tests, which test the whole system when it's actually running. We can, of course, have multiple others like manual tests or whatever. And in TeamScale, you can differentiate these. All you need to do is upload them or label them while uploading it to TeamScale. And after then, you can aggregate them in any way you like. So you can, for example, only look at component tests or look at integration tests and system tests together because you only care about what those two types of tests cover right now. This can be decided at runtime after they've been uploaded at any point. All right, so much for the technical background. Now I would go into the three scenarios. And the first one is a hotfix tests. Probably all of you are familiar with that. Hotfix tests is basically a bug has been found at the customer. I quickly prepared a fix for it. So because the bug is urgent enough to where I should deliver a fix soon. And now with the bug fix, I obviously don't want to introduce more problems. So I do a test to make sure that the bug fix is sound. And with TGA, this now looks like this. So I've made my hotfix. These are we can see there are some methods changed and a few new ones introduced. In this case, background information, we are looking at an SAP system or part of an SAP system. And as a tester, now I would do what I normally also would do. I look at the ticket description and perform the test as is described in the ticket. So I just try to reproduce the bug and see if it still fails. And if I do that, then I get some coverage in TeamScale now. And now we see that only part of the methods are actually green. So only part of the methods have been covered by my tests. In this case, there had to be some additional edge cases implemented that were not explicitly mentioned in the ticket. And this actually happens quite often, not only with bug tickets, also with feature tickets, where just not all things can be foreseen in the ticket description, or there are some edge cases or special scenarios that are just not described in the ticket and maybe wouldn't even make sense to describe in the ticket. And now this gives me the possibility to decide, do I want to do another test or is it fine as it is? So I can look at the methods that are untested and decide, is it worth to provide an additional test for those? In this case, the tester talked to the developer and they decided together that this needs to be tested. So another test was performed, and after that, all the changes were covered. And this fix was published to the end user. My second example is a release test, probably the most standard model of software development for a long time, and a very simple mental model here. We have in gray, the gray bars, the development phase, maybe some weeks, maybe even some months, where development is happening, and afterwards, in blue, the test phase. After the development phase, a feature freeze is happening where no more changes, or rather only bug fixes, can be committed from that point onwards. And then at the end of the test phase, I hope that I covered all my changes and everything so that I can release the software to the customer. The example I brought here is what Fabi has already shown before, this C# business information system with about 1.5 million lines of code. In this case, development happened for about half a year with about 30 developers, and a lot of manual test cases were already specified. These were, along with the source code or the product, this was then handed over to a test factory in India, and the tests were carried out. Since they tested over a long time and a lot of test sessions, they also tested different versions of the system, because after the first tests had found bugs, they already reported them back to the developers, they fixed bugs and gave the updated system to the testers again, and they continued testing on the new version. And TeamScale is smart enough to integrate all of that. So as I said, this is the same system as before. Also, the changes are the same that Fabian has already shown. Quick reminder, in orange, we have the changed methods, and in red, we have the new methods. And here is the test coverage again, also the same that Fabian showed before for the system. And this tree map is actually the last day of the test phase before they wanted to release. And as you can see in these big red areas, there are tens of thousands of lines that are completely untested, and actually a lot of new methods that are completely untested. What's interesting here to see is that these are very clustered in these areas. And the reason for this is they actually wanted to develop had a project going for developing an automated test suite, but that didn't work out. So the project just did not finish until the time, and no automated tests were executed at all. So they just had these huge gaps in their tests. And in addition to that, there was also a communication error where the test factory in India actually didn't receive any test cases for these areas either, because nobody created manual test cases for these, because they were intended to be automated. So what they did then was delay the release and perform an exploratory test. So the main goal here is to cover changes as quickly as possible. And to do that, they recruited users who actually know what the application is doing. So the end users, the requirements engineers, everyone who is familiar with what tickets have been worked on and what new features should come. And over 2 weeks, they did a lot of test sessions with over some versions of the system. And after that, it looked like this. Changes are pretty much the same, plus a few additional bug fixes. But on the coverage, we can already see there is coverage in a lot more areas. It's distributed a lot more over everything. And especially in the test gap tree map, we can see that there are no more these huge areas of only red. So we have much higher coverage of the changes. But we can still see that there are some areas marked with those arrows that are missing coverage. These three we looked into in detail. And usually you can find explanations for these. For example, at the top area, these were just not statically accessible anymore. So no, you couldn't reach them in the code. So essentially they could be deleted and were just old functionality that had survived in the system. In the middle, functionality was prepared for a future release. this also couldn't be tested at this time, so that was fine. And at the bottom, this functionality was actually forgotten because it just was not very visible in the UI. So nobody had, as I said, explorative testing. They didn't have any specified tests. They just tried to test the application as well as possible in a short time. So they didn't find all of the changes that were made. All right. This release test view is good for someone who has overall test responsibility for the whole system, someone who wants to see the whole system at a glance. And also if you want to test the whole system a few times a year. But also, as Fabian already mentioned before, more and more teams are actually working differently. They're working with feature branches where for each new feature and also bug fix, there is a new branch created, and also the quality assurance happens on those branches and not anymore in one big phase, but there is always quality assurance going on. As a tester, it's now interesting for me what changes have been made for this feature. Not overall, but I want to see what changed for this feature. And I'm interested in this much smaller scope. So not whether there have been changes on any other branches, but whether there have been changes or what changes have been made on the branch that I'm currently working on or testing on. So what we did to address this is we mapped the test coverage to tickets. Ticket here you can imagine is some description of a unit of work in an issue management system, such as the Jira issues or as DevOps work items or whatever you are using in your specific context. And here we have a screenshot from our own development. On the left here, you can see some information about the issue. And on the right, you can see the information about the test gaps. So here you can see, for example, in this 29% means 29% of the changes made in this issue for this specific issue have been covered. The rest of the methods have not been tested at all yet, the rest of the changed methods. And if we want to go into some more detail and click on one of the issues, we can see a tree map. And this tree map only shows changes made in this specific issue and the coverage, the test gaps for this specific issue. So here I can see everything that's relevant for this issue. And additionally, I also see information about the issue itself. And particularly handy, I can also see who actually worked on the issue, which allows me to then talk to that person. So the contact person, if I need to ask, does this part need to be tested? Is this relevant? Is clear for me. In our development process, it's actually part of the definition of done that a reviewer looks at all test gaps or all non-trivial test gaps. So getters and setters can be ignored, but those are anyway excluded from the tree map. So TeamScale tries to find any type of trivial method that does not need testing, like, as I said, getter and setter, and excludes these from the tree map. To do this type of analysis, we need a little more additional information. The most important is the connection to the issue tracker, so to the Jira, Azure DevOps, GitHub issues, or whatever you're using. And then we need some way to map the issue to the source code that has been changed for this issue. So we need to find out which code belongs to which ticket. And the way to do this is we add the ticket ID or the issue ID at the start of the commit message. This is the first way to do it. And then TeamScale automatically maps the changes that have been made in the commits to the issues in the issue tracker. The other way is to add it to the branch name, and then TeamScale also knows all the commits made on this branch belong to a certain issue. And with this, I can then get the issue test gaps. All right, that would be the theory part. Do you have any further questions?
Yes.
Sure.
I think there's not always a one-to-one connection from the change or the bug in Jira and the commitment, maybe some code touches 3 or more change requests or bugs. So is there a risk of a lack of test coverage? Because you see the code, somebody was running through the code, but you don't know if it was really the one test case which was changed or something.
Yeah. So what you can see in TeamScale is, oops, I'll go back one slide. The code change would be added to each of the 3 issues. For example, if you have, or no, let's put it differently. If you make changes in code from different issues, it would be in all of those issues as you, yeah, how do I put this? Because you have the mapping in each of the commits, right? So in each of the commits, you say which issue this belongs to, and I assume that a commit at least always belongs to one issue, even though there might be multiple changes made in one area. And then also, if your tests are done on branches, it's not an issue because you have the coverage for each branch, so you can be sure that the test has been performed for this branch. If you are testing, or if you need to know which test actually covered this issue, then again, you would need the this per test coverage that was mentioned before. I think that is not part of the default test gap analysis to actually say, was this test intended for this feature, or was it actually a test intended for a different functionality? I'm not sure if that was understandable.
Yes, of course.
Okay.
More understandable as my question, I think.
Okay, I'm glad we could address it. Any other questions?
Hello, can you hear me?
Yes, we can hear.
Yes, you mentioned that TeamScale tries to identify some trivial methods that do not require testing. Maybe I understood it wrong, but is there some analysis of the source code included as well? Is there code comprehension, or how should I understand that?
Yeah, this really is mostly for very trivial things like getter, setter, and maybe some, I'm actually not entirely sure, some empty constructors or something.
I see.
But TeamScale also does source code analysis. So we actually also parse the source code and know which method code belongs to and so on, because we also do static analysis in TeamScale. So we basically, yeah, build an abstract syntax tree of the source code, and also up to a certain point understand the source code, so we can do static analysis, which like yeah, to create those findings. So TeamScale is also a static analysis tool, and also includes this dynamic analysis part that that does this test gap analysis.
Okay, great. Thank you very much.
Thank you. Any more questions?
No questions in the chat.
All right, then I would hand over to Jakob for the demo part.
Yes, thank you. Can you see my screen?
Yes, we can.
Yep. Pretty good. So I will just move the Zoom controls. So my name is Jacob. Welcome, a late welcome also from my side. I use TeamScale together with customer teams nearly every day, and many of them use TeamScale also for doing test gap analysis. And I have the pleasure today that I show you many of the things my colleagues presented on the slides in a live demonstration. Live demonstration also means that I need some use case and the system under test. And today I brought Pixelitor. Pixelitor is an open source drawing application implemented in Java. From the functionality, it reaches somewhere from MS Paint to Adobe Photoshop, and you can do some simple drawings and apply different filters. Now, the story for the demonstration is that some of the a ticket or an issue has now been finished in the implementation phase and should be tested. So I'm the responsible person that should find out whether all the changes are thoroughly tested or if there's still a test gap. So just to tell you, I don't see the chat right now. If you have any questions, feel free to unmute yourself and just, yeah, go ahead and shoot the question. Thanks. So to do the test gap analysis, I leave the PowerPoint presentation and jump into my browser. And there I already have the TeamScale login page opened up. So TeamScale itself is a server application written in Java. Right now it is running on my local machine, so that is why localhost is stated there. And the first thing I have to do to reach all the data in there is to log in. And I will just do that. And after the login, I'm directed to the dashboard perspective. Let's see how TeamScale is structured, the UI of TeamScale. So on the right-hand side, you have a large lighter window, and on the left-hand side, you have a darker navigation bar. And each bullet here stands for a different perspective in TeamScale. And each perspective offers a different viewing angle of the metrics TeamScale calculates. So for example, we have just right now heard that TeamScale also includes static code analysis. It does some architecture analysis if you want to. And you can also do something like retrospectives together with TeamScale or create reports. Today, we don't have a look at all of them, but we will later on have a look together in the test gaps perspective. And we will now start with the activity perspective. The activity perspective, I just went there, looks somehow like a log of your version control system where you have different commits stated there. And it is enriched with certain details that are calculated by TeamScale. Like in your Git log, you see the commit message, you see who has done the commit, when the commit was performed, how many files were changed. You see an alert and findings, both stem from the static code analysis. And since Fabian here, who has done the last commit, always includes a ticket number prefixed with a number sign in his commit messages, TeamScale also can infer to which issue or ticket this commit belongs to. So the first, this is a good starting point, and you also can see that we already uploaded some unit test coverage to TeamScale. But we will now concentrate on the dashboard perspective. So a dashboard is freely configurable, so you can just create a new one right now. We can add different widgets here from the right-hand side. And today we will focus on the test gap tree map widget. And this widget and tree map shows the results of the test gap analysis. As other widgets, it has to be configured. So you have to tell the test gap analysis which is the baseline, which is synonym for the starting date, and how long should it respect changes or coverage. So right now we would have the baseline 30 days before now until the current date. You can also say from which coverage sources the coverage should be respected. So if you have different layers of testing, or different types of testing, you can just select unit test coverage or system test coverage, for example. And for today, I prepared 3 different dashboards. All of these just contain one test gap tree map. And this is namely a changes tree map, an execution tree map, and a test gap tree map. We will start at first with the changes tree map. And I already told you that you will recognize things from the slide. This is the first thing you can recognize. So we have here a tree map, and it is now interactive. So in opposite to what you have seen on the slide, if you now hover with the mouse over a node, a method, which represents always a method. So a node, a rectangle is a method. You can see where the method lies in the code. You see in the first line of the tooltip in which file the method is located in. You see the name of the method, and you also see a state. So we have heard in the presentation before that the gray methods are the methods that have not been changed since a certain baseline. So the starting date of the analysis, which is here set to the early beginning of 2016. And beyond gray methods, we also have yellow methods that are methods that existed at the baseline and have been changed since then. And we have red methods that are newly added to the system since the starting date of the analysis. So just as a recap, this methods, the size of the rectangle corresponds to the length of a method in terms of lines of code. And the tree map represents always a tree structure. In this case, the tree structure is the file and folder structure as in the repository. So methods that are in the same file are located next to each other, and files are also located next to each other. This is done by a layouting algorithm. So far to the changes tree map. If we now change to the execution tree map, the color semantics change. So you see the same software system, but now the gray methods mean it has not been executed within or since the starting date, and only the green methods have been executed since then. So I've already told you that I just uploaded the coverage of one unit test, and only 3 methods have been covered. That comes in handy because we can roughly remember the location where the methods are that have been executed. So we have 2 methods executed during the test on the lower left-hand side, and here 1 larger method on the right-hand side. Often the question appears how we can now get to the results of the test gap analysis, and this is pretty easy. We take the changes tree map, lay it on the ground, and put the execution tree map over the changes tree map, and we ignore all the methods that have been not been changed since the starting date. So to show you that, I change shortly back to the changes tree map. So again, a lot of methods, orange and red. And if I now change to the test gaps tree map, we will see that now on the lower left-hand side, 2 methods got green. And those are exactly the methods we have seen in the execution tree map. And on the right-hand side, we see the larger method is not colored in green because it has not been changed since the starting date and is thus not relevant for the test gap analysis with that starting date. So often we are asked, how do I get from the visual representation of the system to the actual code? And this is also very easy in TeamScale. If you hover over the methods, you see the tooltip. If you click on the method, you see a link open method, and there you are directed to the so-called method history. You see the complete evolution of the method, meaning that it has to be added sometime, then it was modified several times, and the last change was done by Fabian. And you also see that some coverage was uploaded, so the method has been executed in a test. If I want to get even deeper into the code, I can click on the method name, and there you have a view like in the code editor where you have the actual code and highlighted the coverage. So if a line is executed in a test, it is has a green background, and if not, it has a red background. So back to the dashboard. And also remembering my task for today. So my task for today is that I have to see whether the changes that have been implemented during one issue have been covered in the test. So now I see a whole system, which is not the right scope for my question and my task. And as I already said, we will go together and visit the test gap perspective. We will do that now. And we navigate there to the issue test gap view. Here, I have some issues listed. So that is because TeamScale is not only connected to the version control system, but also to the issue tracker, as Raphael said. And here I can configure freely which issues I want to see. Right now, the filter is set to open issues, but I could also say I want to see all issues assigned to me or issues that belong to the current sprint. For today, our issue of interest is the issue number 1, improve the Gaussian blur filter. And I navigate into the detailed view of that issue. And I have several meta information like the number, the name of the ticket, the status. So this one is open. Who has created this ticket? It was Dennis, and it is assigned to be implemented by Fabian. And there's also a very brief description what should be done in course of the ticket. The Gaussian blur filter is somehow improvable because it is not really Gaussian enough. Since Fabian includes in every single commit the ticket number, TeamScale could parse which tickets belong to the ticket, which commits belong to that issue. And those are 2 commits here. If we look even further into one single commit, we can parse out which files have been changed. In this course of the ticket, it was 2 files changed. And we can also see that there are several findings from the static code analysis. Today, our section of interest is the test gaps view. And if I open that up, I see I again result in a tree map, but now the tree map is much smaller. I only can see 4 methods here, and those, so 1, 2, 3, 4. So those are the methods that have been changed, touched during the implementation of the ticket. And that is much more better for me to accomplish my task, which is to say whether all the changes have been executed in the tests or not. What I like in that picture is that 2 of the 4 methods are green. That means those are already executed, have been executed. And this is because we have uploaded the unit test coverage for that. And what I don't like is that there are 2 methods left that have not been executed in the test. And I, as responsible, can now decide whether this is for some reasons okay, or if I have to go into some retests. So either I have to implement new automated tests, or I would go into a manual retest. For today, I decide that this is an important feature. The Gaussian blur filter is used by nearly everyone who uses Pixelator, and I want to go into a manual retest in the Pixelator UI. Therefore, I need a running instance of Pixelator, and I start that on my command line using the command run. And I want to check whether the Gaussian blur filter works as expected. So Pixelator has opened up. I have to create a new image, and I will try to, maybe draw the TeamScale logo. It's very complicated. Maybe I shouldn't have tried this. And I now try whether the Gaussian blur filter works. I take filter, blur, and the Gaussian blur filter, and I try that out. I have tried it out a lot of times, and this seems to be working quite well. Let's test the extreme values here. That seems to work pretty good. And for now, I have to draw a big green check mark in my test management tool. This test succeeded. The Gaussian blur filter is still working as expected. I can now close Pixelator. I I'm sure to exit. And what I have not told you so far is that the run command not only started Pixelator, but also attached a coverage profiler to that run. Meaning that with every click I did in Pixelator, the profiler recorded with which methods have been executed during my click. And also this report has been pushed to TeamScale to be uploaded. And this should also be shown in the activity view. I just opened that up again here in the new tab. And I see that there's a manual test coverage upload from just like half a minute ago. If I click into that report or upload, I can see exactly which methods in the have been executed during my test run right now. And with that updated data, we can also now reload that issue details view here, because I would assume that this also has an effect on the test gaps view for that single issue. If I reload that, I see the method that on the left-hand side that has been just yellow right now is now green. And that's pretty cool. So we have closed one test gap. What is not so cool, that there's still one test gap here on the lower right-hand side. So what happened here? There has to be some code change in some other region of the code base of Pixelator, and I can now try to find it out myself or ask a developer or Fabi as the developer whether he changed something else, whether he did some refactoring or implemented or fixed some bug. Here in this case, I can see that the changed methods lie, the changed method left lies within the motion blur operator, which is, or the motion blur op file, which is for the motion blur operator. That is just another filter in Pixelator. So I could now decide whether it's worth testing also the motion blur filter. And also this one is pretty, this filter is also pretty used by the Pixelator community. So I just go and do a quick test of that filter as well. We again need a running instance of Pixelator. We need some image to draw on. I now go for an easier picture, and I decide to, or I have to test the motion blur filter right now. It's under filter, blur, motion blur filter. And if I now change the values here, some in motion unsharpness should appear. And okay, yeah, that somehow doesn't look good. So nothing happens, the image remain unchanged. And what I've now found is a bug. So this test did not succeed. I have to draw a big red cross in my test management tool that this test did not pass and create an issue for that bug. So nevertheless, the test here is finished. I can again close Pixelator, and now the same thing happens as before. So the coverage profiler has written down which methods have been executed during that test run, and also the report was uploaded to TeamScale. So let's reload the page again and see whether it had some effects on the issue details view here. And we can see now the test gap tree map here is completely green. And an important fact that Fabi told you in the slides is coming to the table here. So a complete green tree map doesn't mean that there's no bug in there. It only means that you have run all the methods that have been changed during the course of the ticket or during some, during the time span of the analysis. It does not say that there's no bug in there. But if you turn that upside down, you wouldn't have found any bug in a method that is still orange or red, because you don't have executed the latest version of that method. Meaning that if we wouldn't have applied test gap analysis here in this case, we wouldn't have seen that after our test of the Gaussian blur filter, that method on the lower right-hand side remained untested. We wouldn't have tested that, and we wouldn't have found the bug in the motion blur filter. So what do we have to do right now? We found a bug. We have to fix it somehow. We won't do a live coding here, but I prepared something. We will fix the bug by just going to the command line and apply the fix here. So this script isn't doing much magic, but it just goes one commit further in the Git repository. So it changes the motion blur operator. And what is also happening, so Teamscale is connected to that Git repository and sees that there is a new change in that file. So we reload that again, that page, and we can see that the method that just has been green, because the latest version has been tested, now appears again in orange. That is because the commit, so earlier there have been 2 commits. Now there are 3 commits associated with issue number 1. One further commit has been done. In this commit, this method has been changed. So it appears now orange again. I could now execute the test again, but you can believe me that this time the motion blur filter would work. We could also see that the file diff in Teamscale here. But yeah, so normally I would do a last retest and see whether the motion blur filter works, but believe me, it now works. All what we have done right now in the demonstration has also an effect on the tree maps we have looked on before. So if I now change back to the dashboard where we have the test gap tree map that shows the whole system, you can see that a lot more rectangles now appear in green and not in orange or red anymore. So also in the execution tree map, you can see that not only 3 methods have been executed in the test, but a lot more. What I have now shown you is the issue test gap analysis for one issue that has been implemented. We have found that during the implementation of the ticket, some changes appeared that have not been documented in the ticket description, and we would have missed that in the test if we wouldn't have seen that there is still a test gap remaining. We have done that for Pixelitor, which is implemented in Java, but even if your system is implemented in another language that might be already supported. So for all the languages in orange here, we have test gap analysis running at some customer environment. But even if your language is not listed here, just don't hesitate, but ask us whether we can also support your language here. And now I would be open for any questions. So I already said to you that I don't see the chat. So please speak up, or Lavinia, please tell me which questions there are.
There are no questions in the chat, just other messages.
Yeah, then I have one regarding the, I mean, what I understood now, the smallest, how to say, entity of this, how to say, matrix or of this diagram is practically a method. Huh? So you're not going down to a, how to say, line of code. Is it, how to say, like from a functional point of view, you have, well, not you, but in general, there is, you know, this kind of risk-based assessment on the functionalities. Is it, I don't know, possible or even common practice to do the same for methods in source code? That you can apply some kind of pattern, okay, for supercritical methods. I don't know, I'm accepting that it's not executed or that it's not covered by testing, and for, I don't know, something else, it's fine.
Mm-hmm. So thanks for the question. I think one has to differentiate between a coverage analysis where you aim for a very high coverage and a gap analysis, which we presented right now here. So we somehow are the lower boundary, And we see at many customers that this lower boundary, meaning that we can still find completely unexecuted methods, is worth having a look at, meaning that in many cases we see that is also what Fabi told you in the beginning, that there are many methods that reach production untested, even they have been changed. And the coverage analysis, whether every line is covered, is somehow, more detailed. Or covers a different question, sorry.
No, it's fine. I mean, it's a good point. I mean, somehow, I mean, in my mind, at least, I was mixing it up a bit from coverage and gap. So that's why I was, how to say, curious on this one.
Yeah, but we often get the question whether we can do test gap analysis somehow on a line level or in smaller units that methods. What we have done is there were some research work if we would gain other numbers in sense of test gap percentages, if we just split up methods in like blocks of 10 lines. And then you show and then you analyze whether the block in that block at least one line has been executed. So the test gap there can only be as high as for methods, no, as low as for test methods, and we didn't see any specific changing numbers there.
Okay, so it's, how to say, it did not pay off to have a, how to say, higher level of detail then. Okay.
Yeah. But we only tried that out for 1 or 2 study projects. I think one has to just to do further research on that.
Okay.
Maybe one addition. I think one thing you pointed out though is very valid, to say that if you have very critical code, if you know there's a few methods that are very much at the center of your system, there it usually makes sense to drill down deeper to the line level and make sure that if you have code changes, you also cover those on the line level as well. And we do support that in TeamScale. So if you click on a method, you can go down to the actual source code, and there you can also see the normal test coverage metrics that you have. For example, for testing, you can also record it for higher tests.
Yeah, I mean, I was suspecting this because, but it was not part of today's topic, because you mentioned static and dynamic source code analysis as well. So of course it's interesting then, okay, how often certain methods are called and so on, and based on this you could then take the call, yeah, I accept the risk or I don't. Yeah,
exactly.
Any further questions?
No questions in the chat.
Otherwise, I hand back to Fabian.
All right, I'll grab the screen. For the last part, is the screen visible?
Yes.
Perfect, thanks. So in the last part, I'll go a bit into whether we can quantify the benefits, because that is one question that our very first test gap analysis customer posed, Munich Re. They wanted to know, after having used the analysis for several years, did it pay off? And what does that mean? I mean, the goal here is to reduce production defects. So they wanted to know, did we achieve that? Do we actually now have less production defects than we did before due to the test gap analysis? And obviously that is a rather difficult question to answer, because introducing test gap analysis is not the only thing that determines how many production defects you have. So you can't just take the numbers from before and compare them to the numbers afterwards, because teams change, requirements change, development speed changes. They transform from something less agile to something more agile in the same time, and so on. So you have a lot of different things that affect the number of production defects. So this was a bit of a challenge. We did a large study with them that I'm gonna show the results of today, and we also presented this together with them at I think OOP, if I'm not mistaken. So this is something that Munich Re also shared publicly together with us. And how did we go about this? Now at Munich Re, we were in a very unique position, because we not only had a lot of data about how the systems work and how many production defects we have for after we introduced test gap analysis, but we also had the same data from the study that I showed in the beginning of the talk, from before they started using test gap analysis. And so we were able to use that data to determine how much the benefit was of introducing test gap analysis at Munich Re. And how did that work? Let's recap what we had before they started using test gap analysis. We had this study of their C# system and also some data from related systems where we looked at the same numbers. And we saw that they had that more than 50% of the code changes that they did made it into production untested, and that it was 5 times more likely that a production defect is caused by an untested code change than the rest of the system. These 2 numbers are important. I'll use them in the next few slides. Now, what we did in the study is, first we looked at what was the situation without test gap analysis. We know that half the code changes made it into production completely untested, and all the bugs that were in there also made it into production. So for the right side of this graph, all of the bugs that are in this 50% of the code changes, they slip through completely untested. So if we want to know the number of remaining production defects for these systems, then we know already half of the bugs that were in the system are going to production. For the rest, we know that tests were executed for those code changes, and some of the bugs were found by the tests, while others slipped through. How many did slip through for these code changes? We know that the likelihood of bugs in that area is 5 times lower than on the right side, where we have the test gaps. So here only 10% slip through. So this means before test gap analysis, 60% of the bugs that the developers added to the system and due to their code changes made it into production. And now we can do the same thing based on the data that we have for after Munich Re started using test gap analysis for several years. So here, the first thing we need to know is what is the test gap now? And we looked at very many systems. I don't know exactly how many systems we have at the moment where they use test gap analysis, but it was several dozen that we looked at. And we took the worst number to be very conservative. So we took the worst test gap number that they had, and that was 10% at the time. So for those 10% of the code changes, all bugs that are in there still slip through to production completely untested and become production defects. So 10% are out of the window. For the rest, the same still holds. So the likelihood that a defect comes from an untested code change is still 5 times higher than in the rest of the system. So in here, for the remaining 90% of code changes, 20% slip through, or in other words, that's 18%. And so we found that after test gap analysis, only 28% of the bugs make it into production, and the rest are found by the tests that they have. So due to the changes in testing behavior that the test gap analysis enables, by highlighting the risks when you can still react, Munich Re is saving about half of the production defects that they have across several different applications that we looked at in the study. And I think that's quite impressive. Of course, one caveat, as always, this of course only applies at Munich Re. We can't predict if the effects will be the same in your organization because you have different testing strategies, you have different people doing the tests and so on. There's a lot of different factors that impact this, but it was nice to see that for this concrete customer, we had such a big impact on their production defects with the test gap analysis. Do you have any questions about this study? I see nothing in the chat. Then that concludes the workshop so far. Thank you for participating, and thank you for everyone who stayed on so late until the end of the workshop. I remind you at the end, you get a quick feedback questions. I think Lavinia will enable the very quick ones now, and then when you leave the talk, you get a bigger form where we're really happy if you share any feedback that you have so we can improve the talks. We also have another workshop about a different testing topic coming up at the end of November. If you're interested in that, feel free to register. We'll send you the slides and the recording afterwards, so you can pick the link out of the slides later on, so you don't have to note it down right now. This will be about how to get faster feedback from long-running tests. So if your test suite is ever growing, especially with automated tests, and you have a hard time running all of the tests within the time that you have, we can help you there as well with test impact analysis. We teased it a bit in one of the questions that were asked. So feel free to also join this workshop. It's for free.
Super.
All right, then thank you very much. We'll stay on. If you have some questions that you want to ask one-on-one, we'll go into breakout rooms where you can catch one of us and ask them there. But if you have to leave now, I wish you a nice evening and hope to see you soon.